All right, what's up, VL AP Statistics students? This is your video for week 3, day 1. Our topic is the z-test for P1 minus P2, still in unit 6. All right, so we're going to start with the question of the day. I'm going to get into the 4-step process for the z-test for P1 minus P2. We'll look at an example, and then we'll wrap it up at the end. All right, so here is your Ignite question of the day. Make sure that this gets into Schoology so you can get your points for today. All right, so it reads, water samples are taken from water used for cooling as it is being discharged from a power plant into a river. It has been determined that as long as the mean temperature of the discharged water is at most 150 degrees Fahrenheit, there will be no negative effects on the river's ecosystem. To investigate whether the plant is in compliance with regulations that prohibit a mean discharge water temperature above 150 degrees Fahrenheit, researchers will take 50 water samples at randomly selected times and record the temperature of each sample. The resulting data will be used to test the hypotheses. So our null hypothesis here, so we've mainly been doing tests for proportions. I used a mean here, so we haven't seen too many of these hypotheses for means, but this is mu is equal to 150, and then we're testing that against the alternative hypothesis of mu is greater than 150. So we're trying to show that the water being discharged is too hot, so above that 150 degrees. All right, so number 1 says, in the context of this example, describe a type 1 and type 2 error. And then number 2, which type of error would you consider more serious? And explain. So if you just want to take a minute, pause the video, work through the question of the day, and then I'll go through the answer. All right. Hopefully that went all right for you. Let's take a look at the answer. Sorry, this is a little blurry, but I'll read it to you. So I said a type 1 error involves concluding that the water being discharged from the power plant has a mean temperature in excess of 150 degrees, when in fact the mean temperature is not greater than 150. So basically we'd be rejecting the null, which gives us evidence for the alternative that the water is too hot, but really it's not too hot. A type 2 error is concluding that the mean temperature of the water being discharged is 150 degrees Fahrenheit or less, when in fact the mean temperature is in excess of 150 degrees. So in that case, you're failing to reject the null when the alternative is actually true. So the water is too hot, but you're not catching it. You're saying that it does meet the specifications. All right, so then number 2, I said I would consider a type 2 error to be more serious. If we make a type 2 error, then damage to the river ecosystem will occur. Since it generally takes a long time to repair such damage, I would want to avoid this error. A type 1 error means that we would require the power plant to take corrective action when it is not necessary to do so. However, since there are alternative power sources, the consequences of this error are basically financial in nature. So definitely in this case, a type 2 error would be worse because you would suffer that damage to the ecosystem. All right, so that's your question of the day, just a quick review of type 1 and type 2 errors. All right, so what we're going to move on to now is the 2-sample z-test for P1 minus P2. So if we have 2 samples. So I'm going to go through an example first. I'll set up the 4-step process, and then we'll work through the example towards the end. All right, so on Thursday of last week, the U.S. House of Representatives voted to grant statehood to Washington, D.C. If the Senate passes a similar measure, the over 700,000 D.C. residents would be granted congressional representation. So 1 representative in the House of Representatives and 2 senators. And the majority of D.C. residents are people of color. So you can kind of see the racial racial makeup of D.C., Washington, D.C. White alone about 42.5%, black alone about 45.5%. And then you can see the rest of the races listed there and their corresponding percentages. So the question we want to ask here is, does race influence how people feel about D.C. statehood? All right, so a poll was conducted recently that did explore this issue. So this comes from the article, Support for D.C. Statehood is Lukewarm, but many voters haven't made up their minds. And this is from April 21st, 2021. So this article from Morning Consult randomly polled people and asked the following question. Generally speaking, do you support or oppose Congress granting statehood to Washington, D.C.? And these were, so I do have this article linked. These people weren't necessarily D.C. residents. They were people from all over the United States. So 151 out of 253, which is almost 60%, of black respondents answered either strongly support or somewhat support when they were asked about Congress granting statehood to D.C. 602 out of 1,611 white respondents answered either strongly support or somewhat support. All right, so we can see that there is definitely a difference between those two sample proportions, a little more than 22 percentage point difference. So we can see that there definitely seems to be a difference between those two sample proportions. So now, is the difference in these sample proportions, 59.7% to 37.4%, significant enough to conclude that the corresponding black population proportion is greater than the corresponding white population proportion? So we're looking at, is that difference of 22 percentage points in our samples significant enough to conclude that the populations are different? So we do have a systematic way of doing that, and that's by doing this two-sample z-test for P1 minus P2. And I'm going to run through the steps, and then from the steps, I will I'll actually do the test at the end. All right, so it's step one. You want to identify the procedure, identify your parameters, and then write your hypotheses. So this is, again, called a two-sample z-test for P1 minus P2. Sometimes I'll just abbreviate it, z-test for P1 minus P2. You're going to define your parameters of interest. So your parameters of interest are going to be P1 and P2. You do have two parameters, and we're specifically looking at the difference between the two. You will write hypotheses. So your null hypothesis, it's almost always going to be exactly like that. P1 minus P2 is equal to 0. So if we were to think about that, that would tell us that those two that we would assume that those two population proportions are equal, right? So if you have a difference of 0, that means that both proportions had to be exactly the same. Sometimes it'll say in our textbook, they'll write the null hypothesis as P1 equals P2. I like to write it equal to 0 just so I kind of remember that, okay, well, we're talking about a difference of 0. And then your alternative, you have three different options. So either P1 minus P2 is greater than 0. In that case, that's saying that P1 is greater than P2. Or P1 minus P2 is less than 0. So that would be telling me that P1 is less than P2. Or P1 minus P2 does not equal 0. This is one of those two-tailed tests. This is just saying that your two proportions, we're not trying to conclude one's bigger than the other, one's smaller than the other. We're just trying to conclude that there is a difference. Okay, so that is how you write hypotheses. So either equals 0, or so it's always equal to 0 for the null, and then either greater than, less than, or not equal to for the alternative. All right, so that's step one. You do those three things. Step two, you are going to be verifying conditions. So both samples must be independent random samples. Okay, so we've done the random sample a lot. Independent just means that the two samples needed to be collected separately from each other. You can't have the same people in each of the two samples. They do need to be totally independent of each other. Samples must be no more than 10% of their populations, right? So those two kind of make up the independence conditions. And then we also need, remember, some conditions for normality. We've done this quite a bit. So N1 times P hat 1, N1 times 1 minus P hat 1. So that is, those are going to be your, for the first sample. And then we also have N2 times P hat 2 and N2 minus 1 minus P hat 2. And again, all of those need to be greater than or equal to 10. So you do have to check all four of those. If all of those are met, all those conditions are met, then you can go ahead and proceed with your test. All right, the next thing we're going to do then is carry out the procedure. So we're going to draw a sampling distribution, and I'll kind of show that in a little bit. And then we're going to calculate the test statistic. So remember, that's going to be a z-score in our case. So when you're calculating that z-score, p hat 1 minus p hat 2, that's this part here. That's the difference between your two sample proportions. So if we were doing it for our DC statehood example, that would be about that 22% number. We put it in as 0.22. This number here, P1 minus P2, that is almost always going to be 0. Because you assumed that those population proportions were the same in the null hypothesis, that means the difference is 0. So that almost is always 0, that whole P1 minus P2. And then we divide by our standard error. So I'll get into the standard error on the next slide here. So that is how you calculate the z-score. But now, the standard error, I said we would like to use the following for the standard deviation, right? So this is what we've had in the past when we were doing z intervals for P1 minus P2. We want to try to use this formula. That's kind of our general standard deviation formula. But we don't know anything about P1 or P2. But what we did do is we did hypothesize that those population proportions were equal. Sometimes in the past we've just put in different value. We've just put in the p hat values in for p. We're not going to do that in this case because we did hypothesize that those proportions are the same. So we don't want to use different numbers for p1 and p2 if we're assuming they're the same number. So what we have to do instead is we need to use a statistic called the combined sample proportion, or sometimes we'll call it a pooled sample proportion, to estimate both P1 and P2 in that standard error formula. So this is it. So it's called it's abbreviated as P hat sub C. So again, more notation that we got to kind of keep track of, but P hat sub C is the combined sample proportion. And it's pretty easy. All you do is you just take the two samples that you collected and you put them together. So you add the two x values, so those are the numbers you divide by n to get the sample proportion, and we divide our two n values. And again, I'll show you how that's done when we get to our example. But what we do is with that p hat sub c value is then you can see that in this standard error formula, so I have the z-score formula with this new standard error formula here, I can see that all four of those p values in the standard deviation formula all now become p hat sub c. So I'll just erase those so you can see that better. Okay, so that's how you find your test statistic, and then of course the whole point of doing a hypothesis test is to get a p-value. So the p-value can be used, can be found using normal CDF, just as usual. All right, so that's step 3. Step 4 now is to wrap it up, interpret in context. So just as we've done with the z-test for p, you want to reject or fail to reject the null, which then either gives you significant evidence to conclude a difference in the true population proportions, or you would say there is not significant evidence to conclude a difference in the true population proportions. So again, if you reject the null, there is evidence for the alternative. If you fail to reject the null, there is not evidence for the alternative. Okay, so what we're going to do next is run through this 4-step process to answer that original question. And remember, the original question was, is the difference in these sample proportions, so 59.7 for the black population, 37.4% for the white population, significant enough to conclude that the corresponding black population proportion is greater than the corresponding white population proportion? So yeah, there is a pretty big difference in the sample proportions, but is that enough to conclude a difference in the population proportions? And we're going to go ahead and test at alpha equals 0.05, so a 5% level of significance. Okay, so I have done this for us here, and I'm just going to kind of highlight some of the steps. So usually what I do right away is go ahead and notate my numbers. So I have p hat 1 and p hat 2. So I'm going to let the subscript 1 represent the black population, subscript 2 represent the white population. I also have my sample sizes listed here. And then the other thing that I've done is calculated that difference. So that 22 percentage point difference that I was alluding to, that is p hat 1 minus p hat 2. That's actually the statistic I'm going to be using when I actually do my step 4, when I actually carry out my procedure. Okay, so now remember you need three things in step one, and I have all of these listed here. So you want to name the procedure, so that's that z-test for P1 minus P2. And then I want to define my parameters. So, and this also helps me indicate which is going to be population 1 and which is population 2. So P1 is the true proportion of the black population who support DC statehood. And then P2 is the true proportion of the white population who support DC statehood. So this is what you would actually be writing if you were to be doing this test. Okay, so my null hypothesis is P1 minus P2 is equal to 0. So that's my null hypothesis. I'm assuming that those population proportions are the same. And then my alternative now is I'm trying to show that the population proportion for the black population is greater than the population proportion for the white population. Okay, so that is step one. So take a second to digest that. Then I'm going to move into step two. All right, step two. So remember, a bunch of stuff to do in this step. So the first thing, remember, you want to talk about independent random samples, which we do have. If you dig into the article, there is a pretty complex randomization procedure that they got to collect their samples. They are also independent random samples, so we don't have people that responded to both polls. I said both samples, right? 253 and then 1,611 are less than 10% of the population sizes. So the populations in this case are just like the U.S. Adults that are black, U.S. adults that are white. Not clearly those would be far less than 10%. Okay, and then I calculated all of my numbers. N1 times p hat 1, 151. N1 times 1 minus p hat 1, 102. All right, you can take a look at those calculations. And we had 602 and 1,009. Okay, all four of those numbers are much greater than 10. So our conditions are met. Okay, that's step two. Take a second to make sure that you understand step two. Step three now is where we're actually going to do the test. So I started my step three by calculating this p hat sub c. So this was my, again, my combined sample proportions. So what I did is I just put those two sample proportions together, right? So you can see that first fraction there, 151 over 253, and then that second one of 602 over 1611. So all I'm doing is I'm just putting the numerators together, putting the denominators together. So I'm not adding the fractions together because that would be a different process. I am just combining the x values, combining the y values, or the n values to make a new fraction. So if you think about now what this fraction represents, so this would be out of all 1,864, 753 of them support the DC statehood, which comes out to a sample proportion of about 0.4. So about 40% of both samples put together combined support DC statehood. Okay, so that's my combined sample proportion, which I'm going to come back to in a minute. So the next thing I'm going to do is make my sampling distribution. My sampling distribution is going to be centered at 0. It's always centered at your null hypothesis. My null hypothesis is 0. And then my standard deviation, notice I put in that 0.404 in all four spots there in my formula. And that does give me a standard error of 0.033, so about a 3 percentage point standard deviation of my sampling distribution. All right, so now let's take a look at the sampling distribution. So that's what I set up here, right? So we got our p hat 1 minus p hat 2 axis. We got our z axis. It's centered at 0, and then I'm counting by my standard deviation here, right? I'm counting backwards to get those important landmarks. Okay, so then the next thing I want to do is place my actual difference of sample proportions on this sampling distribution. So I got a sample, remember my difference was about 0.223, And I can see that that's going to be way above, even 3 standard deviations above the mean. So I shaded way over here on my picture. It's not quite to scale, but pretty close. So next thing I do then is find my z-score. So I take my sample proportion, or the difference of my sample proportions, minus 0, that was my null, divided by my standard deviation, and I get a z-score of about 6.7. So pretty far from the mean. So I can already tell I'm going to get a pretty small p-value. So then I use normal CDF. I put in my 4 arguments, 0.223, 10 to the 99th, mean of 0, and a standard deviation of 0.033. And that gives me a p-value, so that's in scientific notation, a really small number. So about 7 times 10 to the negative 12th. So very, very small. Not non-zero, but again, very small. So that is step 3. Excuse me. So again, take a minute to digest that. So again, I did my combined sample proportion, my mean, my standard deviation, my sampling distribution, my z-score, and my p-value. And after we've done this a few times, really what we're just going to be reporting in step 3 is, again, that z-score and the p-value. Okay, that's step 3. All right, step 4 now is your conclusion step. So remember, you're comparing p-value to alpha to see if that is a likely or unlikely sample proportion, or in this case, difference of sample proportions. So you compare your p-value to alpha, so much smaller than that 0.05. Remember, that was our alpha value that we were looking at in the problem statement. So that does allow us to reject the null. So remember, if you reject the null, that gives us evidence for that alternative hypothesis, which remember was that P1 minus P2 is greater than 0. Right, so that we do have evidence then for that alternative. And if we put that into context, there is significant evidence to conclude that a greater proportion of the black population support DC statehood than the white population. Right, pretty significant evidence since we had such a small p-value. All right, so that basically rounds it out. Yes, we do have evidence. Yes, we can conclude that the black population is more in favor of DC statehood than the white population. Okay, so that is step 4. So again, take a minute here, make sure that you understand step 4. All right, so that's basically it for today. So for your asynchronous work, so this is all for week 3. So the problems that are associated with this lesson are these. So the ones on page 636. Again, this is based on today's lesson. I made a typo here. That should be 2 there. And then this page 664 is going to be based on the day 2 lesson, so which I will teach the students in class on either Wednesday or Thursday. Again, make sure that you're doing a 4-step process on those starred problems. So there are 2 of them. So when you do 86A, make sure that you do your 4-step process, and 87A, also do your 4-step process. The ones with the multi-part problems, then they'll have some follow-up questions based on that. Okay, so then, so you probably want to wait for this 664 until you have time to digest the week 3, day 2 lesson, but you can certainly get a start on the problem set prior to that. I'm also assigning some of these daily classroom videos. So the 610, 611 daily videos are all about this process, right? So 610 daily video 1 goes into your hypotheses for your z-test for P1 minus P2. So that'll kind of go through that a little bit. Procedure and conditions. So this is kind of like step 1 and 2, again, for this process. Test, statistic, and p-value. That'll go a little bit into the combined sample proportion, and then also your conclusion. So that'll be this 611 daily video 2. And then if you want to see another full example of a 4-step process, go ahead and watch 6.11 daily video 3. And then if you want to preview our day 2 lesson, we're going to get into a new distribution. So instead of a normal distribution, we're going to be using a t distribution. And this is what I'm going to talk about in the week 3, day 2 lesson. Okay, so that is your lesson on the z-test for P1 minus P2. Thanks for watching.